Good afternoon. I think they made the mistake of letting a nervous accountant who's recovering to become an IT leader talk first. So I think that hopefully will keep it within all the expectations. So I'm with Flint Hills Resources. We really kind of started focusing pretty heavily on the digital transformation effort in 17, and hopefully we can tell you a little bit about it. We're not as far along as some of you guys are. And in some aspects and other aspects, we've got years and years of data, and we're trying to figure out how to go leverage it. So it's a little bit about Flint Hills Resources. We're a wholly owned subsidiary of Koch Industries. I think the important thing here is we just converted to a new EAM solution, which really is creating a technology foundation for us that will allow us to move forward more rapidly and a lot of reasons. But to kind of give you a feel for our size, we have about 845,000 assets that we're tracking inside of an Infor EAM solution. About 690 of those are active. We have 40 or so operating facilities, about 12 that are actually production facilities. So just kind of a quick overview on who we are and what we do. So kind of where we start is, this is where FHR kind of started things. And we have lots of history, lots of assets, lots of data, but the bottom line is we haven't been focused on condition-based solutions. We've been trying to, all maintenance is basically, all maintenance and prevention is largely focused on time. It's how many months between failures. It's really not asset group based. It's really much more, it's much more asset group based and much less specific asset based. And so for example, we may, with pumps, we may have 50 pumps, and the reality is we treat them all as if they're identical because that's kind of that's the only way we can really learn and process the data. And instead, looking at specific pumps and going, gosh, those heavy duty uses in those specific areas really need more focus, or we need to better understand their condition if we're going to properly maintain and manage them. In the specific case of pumps, we talked about this, and this is one that I bring up because it's one that my business is very focused on. We know that we can run a pump about 60 months, and we know that industry best is somewhere in the 100 months range, and that's frustrating for us. We like to think we can do better than that and be closer to industry best. But the other thing it does is it forces us to put a lot of reliability insurance in our spare parts. We keep lots of spare parts around and we know that's a cost to the business, but we keep a lot of spare parts around because when things fail, we want to be able to fix them rapidly. Kind of where we're headed. You guys can read the slides, but the bottom line is here, we're trying to run the assets on our terms. We are trying to leverage data to tell us the condition, and we are always we want to be in the position where we're always comparing expected performance versus actual. Some of that expected knowledge comes from knowing historic failure and engineering expectations and standards. Others comes from using AI, ML, tools like that combine anomaly tracking as well as our performance, as well as our historic corrective maintenance actions to try to bring together the condition of the asset. And then to be more asset specific. It's one thing to talk about pumps that are all on a pipeline and they all kind of do the same thing day in, day out. And it's another to say, I'm comparing a pump that's pushing polymer through an extruder versus pump that's pushing gasoline down a pipeline. So trying to make sure we're connecting to those things and those differences so we understand their conditions and we can use AI and other tools to better predict where we think how they're going to perform. In addition to that, we're trying to make sure we understand trying to predict the failed part. For those of you that don't understand what that means, clearly when something breaks, when something breaks in a piece of equipment, we not only fix the piece or the part that breaks, but we also throw new studs and bolts on there. We may throw new flanges or new gaskets. We may put a lot of stuff in there that's just good maintenance practice, but we really want to understand is what part is going to break versus what part is just good old-fashioned maintenance. And then really what we want to be able to do is understand the lead time around those parts. That's a big play for us. the more you better understand the lead time, the more likely it is you're going to have the parts when you need them, and so you don't have to keep a bunch of spare parts around. And the last piece will be trusting the data. This is going to be a big organizational change management perspective. We got a lot of people who have been around for a long time, and we know having them trust the data versus having them just know when that pump's going to fail because they've been doing this for 30 years, or making sure we get the knowledge they have that tells them, getting that into the system. So how will they share the knowledge, and how do they start to trust the data and maintenance to start trusting data instead of time? So this is just kind of a quick overview, and I just did this to kind of talk a little bit about where we've come from. In the past, we had lots of data in our systems, and we did it mostly for operations and safety, right? How are we optimizing a steady state plant? How are we running it? Are we making sure we're not getting things outside of safe work practices, safe norms for operating conditions so people don't get hurt? And in this case, that may have been on this pump, we may have been talking about outlet pressure, inlet pressure, RPMs. That may have been the three things we had inside the DCS that was telling us how the plant was running and making sure it was running safely. When we weren't really sure if it was running safely, if we didn't know what the temperature of the pump was, or we were worried about things like that, we might send an operator out to gather some data for us. Or if we got ourselves burned in the past, we might send an operator out to gather data every day. Along comes whole plant wireless, which we put a lot of money into the last couple of years. Cheap sensors become easy to add, gives us a way more opportunity to measure a lot more, bring in a lot more data to better understand the condition. In this case, we might start taking the temperature, we might put temperature sensors on the pump itself, on the pipes in, pipes out. We might put vibration monitoring on the base as well as the pump and anything else it might be connected to. And all of those things start to give us a lot more data as we proceed. And then the last piece when talked about, I think it was funny because in the last session that I listened to, they were talking about how digital twins and how that phrase is overused, and they're probably right. For us, it just meant contextualizing our historical data around a given asset. I know we have it for running the plant in its steady state, but we don't really have it for doing additional analytics and putting those additional sensors on top. So, and then we use a historian to track all the data, we feed it in engineering expectations, and then we start to look back on failures. That's where we are now. We are starting that process and starting to really dig into what those failures look like and doing anomaly tracking to kind of get the new data we have compared to the old data and trying to put all those things together. This is a high overview of what we're trying to accomplish. I'm sure all of you have seen this. My engineers at the sites love it. But it's clearly is just something as simple as trying to make the time between failures and controlling when we make economic decisions to go fix something. And so from potential to functional failure, one of the things we're starting to do right now is partnering with Infor around their AI package, trying to learn the likelihood based on historic data we have inside of our EAM solution, what work will be needed and the extent and when we'll need it. When we can then combine that with the conditions that we're operating, making sure we're not getting false positives, which is a big thing for us. It doesn't take long as you're going through this learning process for 2 or 3 blips to jump outside what you would like to see the operating range be, and somebody is yelling, shut down something because we just all of a sudden, we have an anomaly, right? Instead of trying to understand over time, did that anomaly really exist the last time we failed? So where does this leave us? Things we're trying to change. This, again, I come back to the OCM is going to be the biggest piece. Communicating anomalies to the right people. There's a couple of places we need to make sure we're connecting our anomalies. One, making sure that our maintenance team sees the condition-based anomalies we're seeing, and then the monitoring team understands the history and the failures, and to make sure the prediction right now is this pump should fail in the next 3 to 4 weeks. Hey, monitoring team, I want you to pin that pump to the top of your list and make sure you're paying attention to that pump. Making sure we're investigating anomalies instead of waiting to repair failures. That's a big thing for us. Are we going to go out and actually look at that pump when it starts to say, I'm having a problem, now what do we do? And then for us, repairing schedule breaks, taking profitable action versus having a schedule break. We want to repair that pump, we want to repair that piece of equipment when it's the right time to do it. We want to switch over to a backup pump, whatever we want to do, but we want to decide, and we want to make sure then we're also making good economic decisions to then repair that pump. If it's got a sister motor, it's got a downstream impact that we know is going to have, let's make sure we're fixing everything. Or in the case of our pipeline activities, if you're going to go out to a site, and you're going to drive 2.5 hours to go work on a pump, let's make sure all the things that you're going to be around that pump that may need maintenance can be done at the same time. So the technology gets us started, but the OCM brings it back, and the organizational change manager is going to bring it all back into what's going to make it successful.